Today we are going to start the OSTP test review, state test review, day 3. Put your name at the top on the left. Put day 3 on the right. Number 19. A cylindrical container has a diameter of 6 centimeters and a height that is 5/3 times the diameter of the cylinder. What is the volume of the container? So first thing, remember I told you guys you want to pay attention to what formula they are asking you to use. On this question, they are asking you to use the volume. What is the volume formula of a cylinder? Very good. V equals pi r squared times what? Height. V equals pi r squared times height. The two things we need in order to use this formula is we need r, which is what? The what? The radius. And we need h, which is the height. So let's start with the radius. According to the information given, it says the diameter of 6 centimeters. Is the diameter the radius? Exactly. It's not the radius. We need half of it. So I'm going to take 6 and do what? Divided by 2, which gives me a radius of 3. Now let's do the height. Now it doesn't directly give you the number for the height. It says the height is 5/3 times. What does that mean? Add, subtract, multiply. What does that mean? Multiply times the diameter. So let's write it exactly what it says. 5/3 times the diameter. What is the diameter? Very good. And you are going to go ahead and multiply that. You can do it in the calculator, do it in your head. If you are doing it by hand, you just multiply 5 times 6 and then divide by 3. What is 5 times 6? That's 30. Divide that by 3. What is the height? 10. So now we have the information we need. And before we plug it in, let's look at our answer choices so we know. Are we using 3.14 or not? Look at your answer choices. What are these? We are not using 3.14. Why not? Because our answers are in what? Terms of pi. So let's go ahead and start plugging this in. Pi, instead of r, I'm going to put 3 squared times my height, which is 10. And all you do is multiply. 3 squared times 10. 3 squared times 10. What is, now 3 squared is 9. And 9 times 10 is what? 90. 90, and bring down your pi. Well, what is your answer here? A, B, C, or D? B. B. Very good. Go ahead and click your answer into Teacher Made. It should be open on your desk so that when we're done, you just have everything turned in and you don't have to worry about making it up later. Number 20. These data show the ages of students in a community play. Which data point could be removed from the set without changing the mean or the median? Now, when we talked about central tendency, we talked about how the outlier could affect the changing the data, how the outlier could make data increase or make data decrease. But this question is not asking about the outlier. This question is asking, what exactly can I remove without making any changes? It's like Jenga, but with a data set. You know how Jenga, you pull it and you're trying to, you don't want to let the top, y'all know how to play Jenga, right? Okay. It's like Jenga, but with numbers. So it says mean or median. Now, mean is the average. You just add all the numbers up and divide by how many are there. Median, what is the median? The number in the, but there's one thing you have to do. You have to put them in order from what? Least to greatest. So let's do that first. Let's put these in order. We have 3 9s. So I'm going to put 9, comma 9, comma 9. And then we have 3 11s. 11, 11, 11. And then we have 2 12s and a 15. Now they're in order. So first, let's start with the median. First, let's identify what number's in the middle. I'm just going to underline from the outside going in until I find my number in the middle, which is what? 11. Now, that is without removing any of our data. The question is, what number can I remove without changing? The median that we just found was 11. What number can I remove but keep my median 11? 11. Look at it. This 11 is surrounded by 2 other 11s. Hold on, let me show you. Look. Those of you who are like, wait a minute, what? Look, I'm going to start over again. Here's our new, air quote, new median. And that's like, quote, from the outside. I'm going to mark from the outside. Now this leaves an 11 and another 11. 2 11s in the middle, right? If I got rid of that 1 11, it leaves me what? 2 11s in the middle, correct? Well, when you have 2 numbers in the middle, you have to add those together, 11 plus 11, and then divide by 2. Well, what is 22 divided by 2? Did my median change? No. So the number I was able to remove without changing the median was 11. So that's only half of the question. The other half of the question was, what about the mean? So let's talk about the mean. The mean is the average. You have to add up all your data points and divide by how many are there. So what I'd like for you to do is take the time, and I want you to add 9 plus 9 plus 9 plus 11 plus 11 plus 11 plus 12 plus 12 plus 15. Go ahead and add up all your data sets. Add up all your numbers. What did you get? Those of you who are 99. So how many numbers are there? 9. So you add them all up and divide by 9. What does that give you? So right now, what we're trying to do is determine if 11 is the answer. If we remove 11 from the average, remove a number 11, that means you're going to subtract 11 from 99. So if I subtract 11 from 99, what does that give me? And then if I take out an 11, do I have 9 numbers? What do I have now? So it's still what? So looks like our answer is what? 11. You ever say a number you ever say a word so much it starts to sound funny? By the time we were done with this one, did 11 start to sound funny? 11, 11, 11. It just sounds like you say a word so much you're like, am I saying that right? All right, so your answer is B. Just so y'all know, the little side conversations get cut out of the videos. Like when I go through and rewatch it, I'm like, clip. So if you want entertainment, you must show up to class. All right, Brandon, here we go. Number 21. Brandon used an indoor rock climbing wall 7 times. His climbing times in minutes are shown in this list. So these are his climbing times. Why is the median the most useful message of central tendency for these times? We're going to go through each answer choice and eliminate the ones that are false statements that are not true. So let's look at A. It says the median is not affected by an outlier. When we did this, when we first started doing central tendency, we found that the median was affected by the outlier, but only a little. There are also situations where the median could not be affected by the outlier, depending on your data set. So we will just put like a little star by this one because it's not 100% false, but it's not 100% true either. So let's read the rest of our data choices and see. Let's see what we can eliminate here. Letter B. The median is equal to the range. So let's take this data set and put it in order. Let's go ahead and put it in order. 13, we got two 13s. We have a 14, a 16, 17, 18, and 35. And now let's find the median, the number in the middle. What is our number in the middle? 16. So that's our median. And it says the median is equal to the range. What is the range again? When you take the larger number and subtract the smaller number. So let's go ahead and do that. 35 minus 14. What's our range? Our range is 21. Our median is 16. Is B a true statement? No, B is not true. The median is not equal to the range. What about C? The median is the time that occurs most often. Is it? What is the median? The number that's where? Which one occurs most often? The mode. The mode occurs most often. So this is a false statement that cannot be true. Let's go to the last one. The median is a larger value than the average, than the mean. So the median is 16. Let's do the mean. Add all those up. 13 plus 13 plus 14 plus 16 plus 17 plus 18 plus 35. 126 divided by how many are there? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 6, 7. All right, 126 divided by 7 is what? 18. So the average is 18 and the median is 16. Is the median larger, the median that is 16, larger than the average of this data, which is 18? So is that a true statement? What was the best answer? A. That is the best answer. Number 22. This scatter plot shows the number of people at a mall each day and the average temperature for the day. Based on the scatter plot, which statement is true? We are going to rationalize our way to the answer. Eliminate the false statements, and the true statement is going to be your answer. First, let's look at our chart here. We are going to start with, on this side, we have our number of people. On the bottom, that is our temperature. From 0 to 50 degrees. All these dots in the middle, this represents the amount of people that were in the mall. From 50 to 70 degrees, this represents the amount of people that were in the mall. From 70 to 90 degrees, this represents our amount of people that were in the mall. Let's analyze this. When it's really cold, was there a lot of people at the mall? This is the amount of people. Now, as the temperature increased, what happened to the amount of people in the mall? It decreased. So then it warmed up a little more. What happened to the amount of people in the mall? It increased. Guys, think of it like this. When you're inside a mall and it's cold, the heat is going. You're warm. When it's nice outside, do you really need to be in the building? No, people will be outside. That's what represents this right here. Then when it got hot outside, where did people go? Inside. Why? Because the mall, they're not running heat anymore. What are they running? The AC. We're going to use our common sense. We're just, Okay, so now let's look at our answer choices. A, the number of people in the mall always increase as the temperature increases. Is that true looking right here? No, it's not true according to the chart. The A is incorrect because according to this chart, always is incorrect. Let's look at letter B. The number of people in the mall always decrease as the temperature rises. Again, is that true? No, because it was cold and the people were high. Then it got a little warmer, number of people went down. But when it got really hot, the number of people went up. So that is not always true. B is eliminated. C, fewer people are in the mall when the temperature is between 70 and 90. Okay, so here's 70 and 90. Here's our people. Is that true? No, that is not true. So last one. Fewer people are in the mall when the temperature is between 50 and 70. Is that a true statement? Yes, it is. Your answer is D. Number 23. Nancy has a bag of different colored golf balls. Each ball is white, yellow, or green. Nancy takes the ball from the bag without looking, records the color, and then returns the ball to the bag. Why is that so important? Why is it so important for them to tell you that she put the balls back? Independent and dependent. Returning the ball to the bag tells you that this is an independent event. If she was to not replace the ball, then it would be dependent, because dependent events change the denominator. It changes the number of items that are in the bag. This one, every time she puts it back, the amount of items in the bag remain the same. That's why they have to make sure to tell you. She repeats this process until she has recorded the color of the ball 10 times, also an important number. Her results are shown. The white, 7, yellow, 2, green, 1. Nancy will take another golf ball from the bag without looking. Based on Nancy's data, what is the probability that she will take a green golf ball from the bag? We are dealing with the probability of an event equals favorable over total. Total times the experiment or total amount of items in the bag, depending on what the question is saying. This question is asking us, what is the probability of G? G stands for what? Green. The probability of a green golf ball. So let's write our ratio. First, let's write down the total. How many times did she pull the balls out of the bag? 10. That's our total. What is the event that they are looking for? The green golf balls. How many times did she pull a green golf ball? 1. So there it is. A, B, C, or D? A. Very good. Number 24. A student randomly selected one marble from a bucket of marbles 50 times with replacement. Again, they are putting it back. These are the results of his experiment. 5 green marbles, 8 blue marbles, 12 red marbles, 25 purple marbles. Based on these results, what is the probability of selecting a green, blue, red, or purple marble? What they want us to do here is identify the fraction, simplified fraction, decimal, and percent of each probability. We are using the same P of E equals favorable over total. We're still using that same formula. So let's start with the color green. What is our total? What is our total times that we did the experiment? 50. That is your denominator. How many times, according to his experiment, did he get the color green? 5. Now, you need to simplify this fraction. 5 over 50. I can divide top and bottom by 5. When you simplify this fraction, what do you get? 1 over 10. Good. Is 1 over 10 represented in the top column? Yes. So we're just going to bubble that in. Now we're going to go to blue. Again, our total is still 50. But how many blue did he get? 8. We are going to simplify. I'm going to divide top and bottom by 2. You can use your calculator if you'd like. Either way, we're going to get 4/25. Does anybody see 4/25 up here? No. You need to convert 4/25 to a decimal. What is 4/25 as a decimal? 0.16. Now, is 0.16 up here? Yes. So we're going to color it in. Red. Still out of 50. How many red did he pull? 12. I am also going to divide top and bottom here by 2. And you can simplify in your calculator if you like. 12 divided by 2 is 6. 50 divided by 2 is still 25. 6 over 25, it's not available. So that means we have to change it to a what? Decimal. Change it to a decimal. What is the decimal? 0.24. I'm going to zoom in. Is 0.24 available at the top there? No. So that means we have to change it to a percent. How do we change a decimal to a percent? Move the decimal 2 places to the right, which will give you 24%. Is 24% up there? Yes. So we are going to bubble that in on the red row. 24% column. Last one, purple. Denominator is still what? 50. How many purple? 25. It is not already simplified. What is 25 out of 50 simplified? 1/2. Very good. What is 1/2 as a decimal? 0.5. And then 0.5 as a percent? 50%. So let's look and see which one is up here. What's up here? 50%. Number 25. School cafeteria workers conduct a survey on Monday to learn how many students will want to buy pizza on Friday. Remember when we talked about sample types? When you were taking a survey, you're looking at different ways to collect your information. One of the ways is a biased sample. What does a biased sample mean? It's when you're setting a limit, right? It's when you say, I'm only going to ask people with black shoes today. You're setting a limit. That means anybody who's not wearing black shoes, they don't get a chance. Well, what is a random sample or unbiased sample? That means what? Anybody gets a chance. So when you're taking a sample type, you want to ask yourself, is this biased or is this unbiased or what's happening here? So let's look at this question. Who is surveying? Who is asking the questions? Cafeteria workers. And who are they surveying? The students. So let's look at each one, and we're going to eliminate the ones that just don't make sense. So let's look at letter A. The cafeteria workers chose to survey every other student who buys lunch. Why is that a no? Why is this a biased sample? It is biased because it says who buys lunch. Who are we leaving out? The people who don't buy lunch. So that means the only people that are going to get asked are the people who buy it. So that's a no. Let's look at B. Every teacher who brings a class to lunch. Who are they surveying here? They're supposed to be surveying the students, but on letter B, who are they asking? That makes this a no. Letter C. Every fourth student who enters the school. It seems kind of biased because you're only picking every fourth student, but we're not 100% sure. Let's check the last option because we want to pick the best answer. So we'll put a star. Letter D. Every other student who brings lunch from home. That one is biased. Why is it biased? Because they are bringing lunch. So of the options that are provided to us, the best answer is letter what? C. The last ones are number 26 and 27, and both 26 or 27 will be using this figure at the top. Matthew wants to find the length of a pond. He picks 3 points and records the measurement as shown in the diagram. So here's our diagram. There's our 3 points, but look really closely. What kind of shape is this? It is a right triangle. Look right here. Which measurement is closest to the length of the pond from point X to point Y? Point X to point Y. That's what we're looking for. We have to identify our 3 sides. Now, the side that they have us looking for is point X to point Y. What side of the right triangle is that? The hypotenuse. That is C. What do we know about the hypotenuse that led us straight to it? 1, it is what? It's directly across from the right angle symbol. 2, it is what? The longest side. That means whatever the hypotenuse is, it has to be bigger than 14 and it has to be bigger than 36 because it's the longest side. So that is C. We'll give this one A and this one B. And now let's go down here and see what we have to do. If we were solving for the hypotenuse, what formula do we use? A squared plus B squared equals C squared. We are using the Pythagorean theorem. We are using the Pythagorean theorem. We know that the hypotenuse has to be the longest side. Look at your answer choices. Are there some answer choices that we could eliminate based off the knowledge that side A is 36, side B is 14? We can eliminate A and B because 10 is not bigger than 36 and 22 is not bigger than 36. And C has to be a bigger number. So at this point, you have a 50% chance of guessing the right answer. So now we're going to use our formula and we are going to calculate. A squared, instead of A, I'm going to put 36 squared plus 14 squared equals C squared. Let's go ahead and calculate that. 36 squared is 1,296 plus 14 squared, which is 196. Now we're going to add those together. That's 1,492 equals C squared. What do I need to do here? Take the square root. What you do to one side, you do to the other. So what is the square root of 1,492? What did you get? 38.6. Now it says what is the closest? What is the closest? C or D? Yep, C is your answer. Last question, number 27. Matthew finds the deepest part of the pond to be square root of 185 meters. Which measurement describes the depth of the pond? Let's look at our answer choices to figure out what they want us to do. The answer choices are A, between 13 and 14, B, between 14 and 15, C, between 92 and 93, or D, between 93 and 94. We want to take that square root of 185 and change it to a decimal. Because changing this to a decimal is the fastest way to finding out between which two integers this square root may lie. So what is the decimal? What'd y'all get? Now that we know between which two whole numbers does this square root of 185 fall, between what? 13 and 14. So your answer is A. Make sure you take pictures and attach it to your work. Click in your answers and submit your teacher made.